Welcome to our panel on cybersecurity. My name is Lauren Cook. I will be your moderator. I'm a PhD candidate here at the Diplomatic Academy, researching cybersecurity strategy and international law in cyberspace. During our panel today, we will be discussing the role of cybersecurity in protecting critical infrastructure. As digitalization increases across multiple sectors, such as health, transportation, and energy, cybersecurity is becoming more and more vital to the basic functioning of our society. Joining us today to discuss the challenges and solutions in this area, we have our three esteemed speakers, who I will now briefly introduce, followed by some opening remarks. But first, let me thank you for being here. Our first speaker is Marco Ender. Marco is the head of Wien CERT, the Computer Emergency Response Team of the City of Vienna, and security in general at MA1 Wien Digital, the digital arm of the city. Before joining the City of Vienna in 2012, he worked as an IT security consultant for 10 years. So Marco, please.
Okay, well, hi. I haven't prepared any speech or anything. I just try to answer all your questions you have, just to give you a little bit of insight to the front, to the people who have to implement the cybersecurity on the critical infrastructure. The City of Vienna hosts quite a lot of critical infrastructure, especially in the health sector. We have 8 hospitals we are supporting. And so I can give you some insights how it is, not on the diplomatic scale, but on the scale where the people who have to do it and what are the struggles, what are the problems we have to overcome to reach the goals, especially regarding the NIS2 directive, the new directive of the EU, which regulates how security has to be done in critical infrastructure. It's a mouthful, and it's really a big topic, and if you talk to anyone in IT or IT security in special, it's the topic right now. The securing the critical infrastructure of your business, your organization, wherever and whatever you do.
Great, thank you. Our next speaker is Lara Siebrecht, and we are welcoming her back to the DA today. Lara finished her master's here in 2022, where she wrote her master's thesis on cybersecurity. She is now a technology risk consultant at EY in Munich, specializing in cyber assurance audits and consulting revolving around critical infrastructure protection and NIS2 compliance. So, Lara.
Yes, thanks, Lauren. I hope you can hear me. But yeah, so I'm very happy to be back here at the DA after 2 years. I was also at my time at the DA involved in a lot of student activities, including DASICON. So it's really a real honor for me to be back here today as a speaker. And well, as Lauren already said, I did write my master's thesis back then, especially on the NIS directive, and also just in general cybersecurity strategies. And that's also kind of how I got into EY. And at EY, I've gained a lot more experience, I'd say, not just from the academic side, but really in the field side. Yeah, so what I do at EY is I also deal a lot with critical infrastructure. We do a lot of what we call critical infrastructure orders. We call it CRITIS. So if I refer to CRITIS today, that's what I mean by critical infrastructure. So a lot of CRITIS audits. We also do consulting around CRITIS. I am involved in a lot of SOC 1, SOC 2 audits, but also like audits evolving around like the C5 standard. In terms of like my perspective on the whole topic, I think that NIS2, or the Network Information Security Directive, the second version of it that the EU brought out, is just the beginning of us securing critical infrastructure, because the EU has really now given us a basic requirement of what critical infrastructure needs to do in terms of their protection. And the Commission already said that after NIS2, a lot more requirements will be coming. So this is really a first baseline. And we already see, like in Germany, we have mandatory audits for critical infrastructure. So in Germany, they're already forced basically to implement certain requirements. But what I've seen, especially in terms of clients, is that we need to support operators of critical infrastructure a lot more. They need a lot more guidance. We need a lot more cooperation. And I think once we have that cooperation between member states and critical infrastructure, that's really when we'll be successful in protecting critical infrastructure. So thanks a lot.
Thank you, Laura, and thank you for coming back to the DA. Our third speaker is Clemens Leitner, who is a cybersecurity consultant at EY. Before that, he was a cybersecurity expert at Siemens. He is an expert in informational technology and cybersecurity and holds a Bachelor's of Science in Technical Computer Science from TU. Clemens, please.
Thank you for having me. Yeah, I'm currently at EY on the other side of Marco, basically. We do a lot of red teaming, which means attacking companies for hire to check their cybersecurity level, and doing also a lot of critical infrastructure, especially power networks, power network provider and banks. And basically, the thing we see most is nation-state actors attacking critical infrastructure. I think in May of last year, Denmark was attacked. 22 power companies got hacked by the Russian government or Russian groups. And I think this is the biggest threat that we are facing right now, especially in critical infrastructure. I mean, I think the main actors are China, Russia, the Americans, the United States, as well as Israel and Iran. And if we look to North Korea, they are also one big player, but more out for the money and not out for destabilizing countries. Thanks for having me.
Great, thank you. Let's move on to the set questions, and after that we will have some audience questions. The first question is, what do you see as the biggest challenge or challenges to safeguarding critical infrastructure currently? And what are your thoughts on how we can address those challenges? Let's start at the end with Marco.
Okay. The biggest challenge I see in my daily business is to get security into the critical infrastructure, and this is based on two aspects. First, you deal with hardware and software which usually is quite old. You don't buy a power plant and buy a new one every 5 or 10 years. You use the IT that is built into it for a long time. In our case, medical systems, you buy them and you use them a lot of years and they're old, and you have to get security into a system which is not built for security. It is built for running permanently, running stable, but not with the focus of attacks in the defense. It just runs. And that's the other thing. The people who use the systems and the people who maintain the systems have the same mindset. It runs, never change a running system. You don't want to change anything. You want it stays there. You don't want to implement new security measures. You don't want to patch every month, because on the other hand, you lose certificates of the tool. You know, the supplier gives you the technology and he says, now it works this way, don't change anything. As soon as you change something, we won't guarantee it works anymore. So how will you do security in this environment? These are the two main things we have to deal with. Changing the systems who are not meant to be changed, and changing the mindset of the people to really live security and not just leave it alone and hope it works. That's the hands-on experience.
Yeah, so to answer your question, I thought of maybe explaining this from a kind of trickling down perspective, because I think protecting critical infrastructure isn't alone the responsibility of the entity. I think protecting critical infrastructure comes from the EU level down to member state level down to the operator. So I think in terms of the EU, I'll first of all start with the challenge here. I think it's very obvious, right? How do we implement legislation within the member state level that is really realistic, So the first incentive here was the first version of the NIS directive, which was in 2016. And so what happened here, we saw that a lot of member states really implemented the directive in a very different way. For example, in Germany, we have like very strict audit requirements. Every 2 years, critical entities need to be audited, which of course also forces them to comply and have certain cybersecurity measures. But on the other hand, we didn't see very similar activities in other member states, which is why now the EU has come forward with the NIS2 directive, so that we really have like a minimum basis requirement for critical operators. Then, as I already said, I see like a big challenge on the member state level. So here the question is, how do we monitor all of our critical entities, critical infrastructure? How do we do that? That's really like become a big question, especially with NIS2 now. You know, a lot more companies have fallen into the scope of NIS2. So I can tell you from a German perspective, the Federal Agency of Germany for Cybersecurity really struggles to to monitor all entities. So what is the answer here? I think that we need to have a lot more funding in terms of the funding that we have in cybersecurity and monitoring these critical infrastructures. But also what I really see is that we need a better relationship between the member state regulator and the critical operator themselves, because what I see from clients at the moment is they are often, they're confused. They don't really feel like they can talk to the BSI, that's what we call it, Bundesamt für Sicherheit und Informationstechnik. So I feel like there is the communication is not there, and if we can elaborate or leverage upon that communication and that cooperation, we could tackle that challenge. And then I think you already mentioned a lot of challenges that we see within critical operators themselves. You touched upon old equipment. We have to see it's not the same processes as we have as in IT. But something, for example, I really see my clients struggle with is scoping of the critical infrastructure. So what exactly is within the scope of our critical infrastructure? How do we define that scope? So how do we really define all of these processes and systems that we need to protect so that the critical service can be delivered? And after that, how do we really implement cybersecurity measures within those processes and systems? And what I also see our clients struggle with here is really that communication, finding the right responsible people to implement those cybersecurity measures, just a lack of communication within the company itself. So yeah, that's a brief summary from my perspective, if you see it from the EU member state and operator perspective.
Wonderful, thank you. That's very interesting. Clement?
I would agree with both of you. I've seen it at Siemens and at other companies. Usually the companies themselves don't know what to protect. They don't know what systems they have, and if they know it, they're really old. As Marco said, operational assets are usually 30 years old, sometimes even older. Security isn't built in, and once they know they have to protect them, often it's the case of, okay, how can we do this so we don't go bankrupt? Because protecting a power plant, for example, or a manufacturing facility is very expensive. It's very complicated. Usually there are not a lot of people there that know what works and don't have a whole scope of the system that is in place. So most companies struggle a lot with identifying the assets that need to be protected. And this makes it really complicated and hard, especially then if for NIS2, a lot of new companies are affected. They don't know what's content of NIS2 and only have a limited amount of time to implement it. I think it's in October 2024, so this year. It has to be implemented by the states and also by the companies who are affected. A lot of people don't know what the contents of this new directive are, which makes it really hard for companies to implement. And I think the second big issue or the second thing that is facing us right now is international conflicts in Ukraine and Russia, as well as Israel and Gaza. Because those international conflicts fuel a lot of attacks on critical infrastructure in those states. If you look at Ukraine, for example, the biggest telephone carrier was hacked by a Russian hacking group, I think 2 months ago, where 24 million people didn't have access to the mobile phone network. but in the other direction as well. So Ukraine hacking groups are hacking, for example, the Russian tax system, so people can't file their taxes. And I think those big conflicts also fuel attacks against other European countries, for example, Denmark or Spain. And I think those are big issues. And I think it needs a lot of collaboration on the European as well on the state level, and a lot of communication between entities that are affected by those attacks to mitigate them or protect against them.
Okay, thank you. That was a very comprehensive overview and pointed out a lot of issues that I think we don't really talk about often.
I just want to add one thing, or one number to keep in mind. The BSE from Germany estimated that approximately 20% of the money and resources a company spends in IT should go to security now, because of the NIS. 20%. That's from yesterday to today, a fifth of your resources should be spent in security. That's a huge change. It's unrealistic, honestly. But it just shows how much the security changes in all this critical infrastructure for the companies and organizations. What they have to do right now and really fast, as mentioned by you. It's really, of course, I'm from security, all these things should have been done 20 years ago, yeah? All these regulations or all the best practices, they were there, they're not new. But now they have to do it, and you have to do it fast. And it's not really realistic to do it in this short amount of time. It's good that it has to be done. I really love the regulations, yeah, it helps. They help me quite a lot to push forward the security in the organization. But that they have to be done in this short amount of time is really a hard thing to do.
Yeah, I think, I totally agree on that. I think that also, we see a lot of CISOs that struggle with this, and like you said, it's not realistic if you look into the real world to put that much funding into cybersecurity. But that's also where I think the problems lie, right? Not enough funding, not enough awareness. So maybe, directives like the NIS2 directive will, change that perspective a bit.
Of course, hopefully, and of course.
Thank you. That also plays into our next question, which is that given the fast-paced nature of this particular area, to put it mildly, primarily in technological advances, but also in evolving legislature, what are some strategies that we can implement to keep up with this pace and keep infrastructure safe?
Me? Okay. I want to soften the problem a little bit, because the main thing right now is the directive. It's not the technical changes that are going that fast. To be honest, in my opinion, the attacks didn't change that much the last 10, 15 years. All the attacks that have been there and that there are right now are quite similar. As I said, all the measurements you should implement are quite the same now. You just have to implement it everywhere, and a lot more systems that you did it until now, because usually you say you secured your IT, your office computer, because the main attack surface for the IT in our experience, and it is everywhere, so I think is the end user with his system and the internet facing systems you have. It's not the OT that stands in the third room on the 15th floor, separated from everything else. If an attacker is inside, and assume breach is a new thing you have to do when you live security, then it's very important to keep the attacker from getting there. But the first line of defense always was the end system, and now you have all these security measures to the OT security, to the operational technology. And that's the big challenge, but not the technology advancement of attacks, my humble opinion.
Yeah, so I think touching up upon that, yeah, you're absolutely right. I think this is more like a regulatory question, right? So I'd say all of the requirements that are within NIS2, we're already pretty aware of, and companies are pretty aware of. It's a matter of the scope, where you already touched upon how you're going to implement those. However, I do also think, I was just in the AI panel, I think that's a very hot topic though in terms of new technology. So within my company, that's like the #1 topic. How do we regulate AI? What are we going to do? How are we going to help our clients within AI? And I think in terms of like keeping track of technologies and keeping track of the regulation, I think that companies honestly just need to perform regular risk assessments so that they can really incorporate all of these new requirements. They need also a process which we often see with our clients that's missing. They need a process that really monitors regulatory requirements, everything that's coming, that in terms of like region and sector, both. And also, I think a new hot topic that is going to come upon with companies is like building a risk management framework that incorporates all of these new requirements. So at the moment, you really see like individual different audits, but if we could, or the companies could make a risk management that incorporates all of these requirements, not just specific requirements, I think that would make it a bit easier for companies, and also especially building on a risk management framework that can easily incorporate new requirements, such as, for example, AI. Yep. Yeah,
I think I agree with everything they said already. The technology isn't new that we need to protect. The legislature is also not that new. I mean, NIS2 is new, but those rules have been in place also for a long time. And to mitigate all the problems, I think education with employees is very important, the first line of defense. And especially in that area, a lot of companies haven't done that. And it really shows. I mean, the most malware or ransomware attacks are through employees of the companies. They click on a link, they click on an email, and 2 hours later, the whole company is infected. And I think those are low technology measures that can be taken by companies, organizations to protect against cyber attacks, also in the critical infrastructure sector. But also with new technology, with AI, I think those can be leveraged for that area to identify assets, to teach employees, to find vulnerabilities. And I think this is a really, really important part and can be used to do so. And yeah.
Maybe before we go forward, is everyone here aware what the first line and second line of defense is? But maybe should we explain what it is? So within our company, you have what we call the first, second, and third line of defense, right? When you look at risk management. So first line of defense are all the employees that really like do the operative work. And the second line of defense are those employees that are really in charge of like the risk management, implementing processes for in terms of cybersecurity, for example. And third line of defense would be more independent, like auditors that can do independent audits within the company. So when we're talking about a miscommunication between first and second line, it's that we really see like the second line of defense, so those who all implement those processes, that they have a hard time reaching the first line of defense, the actual people that do the operative work. So that's just as a clarification.
I just want to say something about the AI. AI is a huge buzzword right now. Everybody talks about AI. Just to put it in context with security. Again, my humble opinion, may I be proven wrong in 2 years, but right now I don't see new attack vectors because of AI. I see, and what we see in an advancement in the existing attack vectors, especially social engineering. All the video fakes, audio fakes you can do right now, and you can do them fast and you can do them cheaply. They are a challenge, but there's not a really new attack. Same goes with attacks against infrastructure or your internet-facing website or anything like that. AI as today didn't find new vulnerabilities or didn't find new methods to attack you, but they make it much easier for people who are not able to do it by themselves to use the AI. This EDA. Here you have some pages and some books about cybersecurity. Now use these books and start an attack, and it's working. They are not new attacks. It's nothing we did not already defended against, but it works much easier right now. So I'm quite relaxed regarding AI. You have to know how to use it, but it's not one of the big concerns for my job.
Great, thank you. I think that was very illuminating for those of us, myself included, who maybe don't have a background in tech. And so when you're not as familiar with what has existed in the past, then you're confronted with these things, and cyber awareness is something very important. I'm probably not the best at it, truthfully. So I think now we will move to our audience and take some questions. So I think we have the mic, and we have some, yep.
My name is Gregory Weeks. My question actually is related to the city of Vienna, but also for the other panelists. Several years ago, there was an attack on the city libraries of Vienna,
Yep.
where they stole all sorts of user data. And my impression is, and this isn't just for the city of Vienna, but for other organizations, that we're more reactive than proactive regarding things like that. Once a big event happens, then everyone gets in a big tizzy and does something about it, but beforehand, nothing is done because no one's willing to commit the resources. And I'd be interested in what you have to say about that.
No, I have to disagree. I can't get into much detail regarding this attack, but there has been done a lot of stuff beforehand, and of course, it has helped us to get more funding and to more resources after the attack. So yeah, I personally was affected by the attack as a private person. I have a member card, so I'm affected too. But as you said, there hasn't been done a lot beforehand. There has been a lot done, and it's still IT security, and that's one of the main issues I have with IT security. A lot of the measurements you take, a lot of the controls you establish are protecting the stuff, but you can't protect from everything. It doesn't work. There is no such thing as 100% security. So instead of preventive stuff, you also have to have things in place to detect attacks and to react accordingly, and to react fast and to detect them as soon as they happen. That was one of the first and the biggest reasons this attack wasn't detected as early as it happened. It took a long time. In fact, we were informed by the attacker that we have been attacked quite a long time after he attacked us. And we have done quite a lot in this area right now. We're not there where I want to be. We have not reached the goal, but that's one of the main things we have really put effort in to get better there. And away from the preventive, still use it, of course, but there's a certain level we have reached, and everybody has reached, since IT security is all about preventive measurements, preventive stuff since the 90s, to get to the more assume breach thing, as I told earlier, to detect the stuff and react as soon as possible. Isolate the systems that are attacked, isolate the impact that happens when you are attacked.
To add to this, I think you can't prevent an attack. It's impossible. There's measures to isolate systems, to build a network of computers that is resilient against attacks. But to put a buzzword here, 0 days exploits will always exist. A short explanation, a 0 days an attack or a hack on a system that nobody knows about, only the attacker or a small amount of people, and it's being used over some time until it is discovered by the company who produces, for example, the software or the hardware, and then fixed. And especially, I think, in the last 10 years, 0 days exploits are used more sophisticated and chained. So multiple 0 day exploits are used in succession to gain system access, and I think you can't really prevent this. This is always going to happen, but what you can prevent is that it spreads over a whole network. So only a small system is affected, the damage is small, there are backups in place, the system gets nuked or deleted or whatever, and a new system is in place very fast. And I think this is the way to go. But you can't prevent it. It will always happen. And with the big hacks or the big attacks on companies, yes, of course, there's more news about it, there's more money for it, but measures have been in place since the 90s in most companies. There's some companies that are a little bit more lax, but in most places it has been in place for a long time. And some exploits, especially from nation-state actors, are so sophisticated that even Microsoft, who produces software, can't detect them. Or in the example of Pegasus attacking journalists, Apple still hasn't fixed this exploit to 100% because they can't find it on their own. They know it exists, but it's still being used.
Mm. Yeah, maybe also to touch upon that, when we look into the cybersecurity or information security of companies, what we really look at, as both of you already mentioned, is more like how do we detect an attack as quick as possibly, and how do we react as quick as we can to prevent further damage. So first of all, we look at things like, as you already said, for example, network segmentation. So if like one system is attacked, that's a way to ensure that perhaps the hacker can't go into other systems. But also something interesting that has come from the German government, a new requirement, is the new requirements on attack detection for all critical operators. So here you have really specific requirements on how to detect an attack. So you basically have to implement logging. So and then you have to have a attack detection system that has the right use cases to attack certain certain activities, and then you have to have a process that really for the reaction. So how do we prevent how do we have the least damage possible? So these are really when it comes to cybersecurity, I feel like also when I went into this topic, I always thought about, it's all about coding and all of this and that, but it's actually really about having the right processes and having the right responsible people.
Great, thank you. Our next question.
Hello. My question is regarding open source programs, because wouldn't be one solution to force companies to make their programs open source, because the idea behind this is basically there's something called white hat hackers. So basically independent people basically look through open source software and they're looking for exploits, zero-day exploits, and potential weaknesses. So wouldn't this be one solution to?
Me first again? Okay.
I don't care.
I have a quite controversial view on this one. Open source can be good, but it can be bad too, because open source is great. You have the possibility to look into the code to find the vulnerabilities before a bad guy can find them. But the other hand is someone has to look into the open source stuff, because the bad guys can do that too. As soon as you release an open source project, a new code, every bad guy can take a look at it. If he's faster than the good guys, you have a problem. Of course, the big open source projects usually have a staging process where a lot of review is in place, and that's good stuff. But you have, and it's shown multiple times, that Log4j is such an example, that you have open source projects. They are made by a few people. They are not managed. Everybody uses them, but they are not managed as good as they should be. And then you have a vulnerability. And when one finds them, he can abuse it. So this open source, closed source, it's not black and white. It has to be both. It's not one is good, the other is bad. It's just you have security problems with both of them.
Yeah, I think open source can help, but it's not a solution for good software or secure software. You already mentioned Log4j. There was also an SSL for encrypting web traffic, a problem in a library a couple of years ago, also open source, and it affected almost the whole world because it was used so widely. I would say in general, open source software which is maintained well and has a lot of developers is a lot more secure than closed source software, because there's more resources behind it, especially with big libraries that also are used by Microsoft or by IBM, because they also staff actively people to those projects. So there's a lot of people actually being paid working on those. But there's also a lot of libraries or software being used. There's only one person that checks and maintains that program maybe 5 times a year. And then you have a case of Log4j, which is used in a lot of web applications. Everybody used it, and everybody was affected, and it was detected really late. And so it can help, but it doesn't necessarily help. What I see at the network providers, that a lot of legacy software is being used that is closed source, and we have issues with the suppliers of those software that they don't want to fix certain issues. And in that case, open source would help. But sometimes you can't force the manufacturers of the software to update certain things, and that's really also a problem.
may I add one thing where the idea of open source is working and has to be used is cryptography. Never ever use any cryptography algorithm that is implemented by yourself. Use the established ones. That's just one thing, a good example where this open thinking works, where everybody can see everything and all are working together to make it as hard as possible for an attacker to abuse it.
Yeah.
Great, thank you. Our next question over here.
Okay. So on Monday, actually, the White House Office of the National Cyber Director released a report asking developers to use programming languages that don't have memory safety vulnerabilities, saying that by adopting memory-safe programming languages, they can kind of prevent an entire class of vulnerabilities. I just want to know your thoughts on this and how actually achievable that would be if we shifted that towards that direction.
Thank you.
I can answer, or we can both answer. I think it's a good idea in general. It's not always possible. Those types of programming language have usually the issue that they're not really efficient. So if you look in the sector of IoT or energy efficient devices, like in the hardware sector, it's not always possible to use those types of languages and still achieve the kind of energy efficiency, for example, or computing efficiency you want. This is also true for AI applications where you need a lot of efficiency in how the program runs, and then you need to use, in some cases, on the hardware level, programming languages that are not memory safe. In generally, for web applications, for normal applications, it's a good idea, of course, and it's being used already in most cases, I would say, but for some applications it's not possible or doesn't make a lot of sense from a technical perspective. You can do other things to prevent memory leaks, which is the type of vulnerability that they want to address. And those can also be detected really good. You just have to do it. That's the thing. A lot of developers don't do it, and then you have those types of vulnerabilities in the software.
Yeah, I kind of agree. In a perfect world, that's a solution to one problem, and it's a great idea to say that, and some big companies already shifted to this idea and said all new projects, that's the main point, all new projects are programmed in these new languages. We have a huge thing here with programs that are 20 years old and are used everywhere, and you can't just from today to tomorrow in a short period of time change all these programs into the new languages. That's just impossible, and it will be hard to transition these programs to the new languages. As a security guy, of course, yes, please, if you have the possibility to use the new program languages, do it. But it will take time and as he said, there are some fields where performance and low energy use are really a thing you have to handle, and there it's maybe not the best solution.
Okay, if we have any other questions, we'll take that one back here. Oh, no.
I just have a follow-up question. You've been talking a lot about software. I haven't heard anything about flaws in chip architecture. And I was also wondering whether AI could be used to find software flaws or chip flaws, and whether that would be helpful to you.
For chip flaws, I can answer. I'm a little bit into that topic. The thing is with chip flaws, they happen. I mean, programming mistakes happen. With chips, it's a lot harder to fix. Usually, so if you look at the process, how a chip is being made, it's being designed and then being built in a factory. And those steps usually take, I would say, conservatively 3 to 5 years. Developing cycle, sometimes 10 years, depending on the kind of chip which is being made. The good thing is, in software, you can usually fix a lot of things if flaws are being found, and this is also already happening. But certain attacks, especially on a hardware level, can't be really prevented. As soon as an attacker has access to the hardware, usually the system is compromised. And there are certain types of things that can be done. For example, the thing is with laptops, if they're stolen, that's the main thing. at some point you can't protect anymore. And finding those issues also in chips is, yes, AI can be implemented into tool chains to find the issues already in the development process. And I think this is already being done at some level. I'm not quite sure. But also, if you look at chip design, the systems being used to develop chips are also very old. The tool chains are very old. If you look at Intel, the software they use for chip design is sometimes 15 years old. So there's a lot of legacy software, I think it's everywhere, that is still being used by a lot of people also in the chip design sector. Phasing that out to new software which incorporates AI for finding those issues, for example, will take a long time.
I think you also mentioned the protection of infrastructure. So yeah, so maybe I can say a bit more there next to our pen testers. So I think in terms of infrastructure, that'll also change drastically with the cloud. So we see like a lot of companies switching towards the cloud, and so I'd say more classic infrastructure won't be used as much. So there maybe that's also an opportunity to protect infrastructure a bit more, but in terms of like protecting infrastructure, what I, for example, see, you know, when we, for example, go to a data center or something, we look at servers, you really need all of that physical protection. And, you know, for some operators, for example, they're not aware that that needs to be protected. They need that kind of physical protection. So I'm hoping that also with a lot of companies going to the cloud, that will also be a problem that will maybe be mitigated a bit more.
Okay, one thing added to the question regarding finding vulnerabilities in software using AI, it's already been used. The example I mentioned earlier where AI is used to find not new attacks but find attacks faster also can be used as white hat to find the vulnerabilities in your software faster. So yeah, of course you have to give them the source code, and still AI is really good at pattern recognition, and so they find pattern. It's not 100% correct or 0%, it's always the stuff with AI, but it really fastens the work. Yeah, it goes. So I have really high hopes in using AI as a defender.
Okay, thank you very much. I think we can end right on time. So thank you to the audience for your questions, and thank you so much to our speakers for your insight and knowledge. And that concludes our panel on cybersecurity.